Hello everyone, welcome to Sri Chaitanya Academy. I Harish Sen. So we will now begin with the second lecture of our transition course in physics. So yesterday we learnt about functions, right? We learnt what functions are. We also learnt about function of a function. We learnt about domain. We learnt about range. So now we'll move on to the next topic, right? We have some special functions which we are going to study about. So before moving on, I would like to tell you that please, solve questions which I give you, because these questions are very helpful, and the main thing which will make you good in physics is by solving questions. Okay, so please do solve questions. This is a bold statement. Okay, I want to make, please solve questions. Okay, so let's start with functions. So basically we are going to talk about some special functions today. Okay, so the special function which we are going to talk about is exponential function, and log functions. Okay, so these are the two special functions which we are going to study about today. So first let's hop on to the exponential function. So first, what is exponential function? Okay, so an exponential function is a mathematical function of the form fx is equal to a power x. Okay, so if I have a function fx is equal to a power x, a raised to x, then this type of function is known as an exponential function. Okay, so now what do you see here? Okay, that this a, what is this a and what is this x? So this is known as the base, and this x is known as the exponent. So now there are some conditions on the base and the exponent part. So let's talk about the base part. Okay, so what is given? That this base a should be greater than 0. This base a should be greater than 0 and should not be equal to 1. So you might have some questions that why is this so, right? So we'll talk about that. So what is this? That the variable x is the exponent and a is the base, which I have already told you. So now why this condition? Why a is greater than 0 and why a cannot be equal to 1? So why a is greater than 0? Okay, so let's take here that let's suppose a can be anything. Okay, a can be any number, but cannot be should be greater than 0 and not equal to 1. So let's take a number. So to verify this, let's say that a is -2, right? Basically I am trying to check this condition, that what happens if I don't follow the instructions here. So let's take a as -2. So when I take a as -2, what do I have here? I can say that the function fx will now become -2 power x, -2 power x. Okay, so now what is the problem here? The problem lies not in this but in this. So let's say, see, I don't have any condition on x, but let's say if I take x as 1/2. So what this will become? This will become -2 power 1/2, and this will become under root of -2, right? So what is under of -2? Yes, is this defined? So what can I say? That this part, this is not defined. And since it is not defined, right, I will face problems. So to overcome this issue, right, there can be other case also. Let's say if I take a as -8, and let's say if I take x as 1/3, 1/4, okay, then there will be issues, right? So to come around this issue, what we say, we put a condition that a should be greater than 0. Okay, I hope this is understandable. But now why a should not be equal to 1? Yes, a should be greater than 0, but not equal to 1. So let's take a equals to 1. So if a is equal to 1, yes, what do I get? My function fx will become 1 power x, right? My function fx will become 1 power x. So now what is this 1 raised to x? Yes, if you think, yes, 1 raised to x is always equal to 1 only, no? Yes or no? Anything raised to 1 is 1 only, correct? So the thing is that this is, so what we are studying? We are studying, the topic is exponential functions, correct? But is this exponential? Whatever value of x you put here, right? Let's say if I put x as 1, x as 2, x as 3, x as 4, or let's say x as 100, any value you put, or let's say, let's take some negative number also, x is -2, right? So what do I get? Here I'll get fx is equals to 1 raised to 1, that is equals to how much? 1. Here I'll get how much? 1 raised to 2 is equals to 1, 1 raised to 4 is equals to 1, 1 raised to 100 is also equal to 1, and 1 raised to -2 can be written as 1 upon 1 by 2, that is equals to 1 by 1 is equals to 1. So what do you see here? We see that whatever value of x you are taking here, yes, the value of my function is constant. It is not exponential. Okay, so what can I say here? I can say here that if you take for a equals to 1, yes, the output is a constant function. Okay, so I don't want a constant function, I want an exponential function. Note, exponential functions either increase or decrease, simple as that. Okay, they are not constant. So that is why we should not take a equals to 1 and not a greater than 0. I hope this is understandable. So now next time you draw the graph, you should be knowing this, that what is the value of a you should be taking. So now let's talk about some examples of exponential functions. So what is this? Fx equals to 2 raised to x. What is a here? So the a is equal to 2. A is equal to 2. Is a valid here? Yes. For fx equals to 3 power x. Yes, what is a? A is equal to 3. Is this valid? Yes. Now, what is a here? So the value of a here is equal to 1 by 2. Is this valid here? Yes. Why? Because a should be greater than 0. Yes. Is this satisfying this condition? Yes, it is greater than 0. And it should not be also equal to 1. Is this satisfying this condition? Yes. Now, what is this e power x? Okay, so now students, like, they find it very difficult, or they are very afraid of this e. Okay, later on you will understand what I am trying to say. Usually students are very afraid whenever they see this e in their question. So what is this e? E is the exponential. E is an exponent. But now what is e exactly? So you should understand that e is nothing. E is just a number. E is just a number 2.718. And this number is very special here. Okay, it is just a number, nothing else. Okay, you don't have to be afraid that, okay, what e is? E is just a number 2.718. To be precise, e is 2.718. Okay, there are many digits after this, but we only need this much. Okay, so like 2 is a number, 3 is a number, 1 by 2 is a number, e is also a number. Okay, so what is value of a here? I can say that value of a is equals to 2.718, or in other words I can say this is e. Okay, so there is nothing to be afraid of. So now mostly when we talk about exponential functions, okay, I will recall this e. Okay, mostly we use e. Okay, why we use e? We will see in the later chapters that it is very important. Okay, in many different chapters it pops up very easily. So we'll talk about it later on, but let's move forward. Okay, let's not make it complicated right now. Let's keep this very simple, that what e is just a number. So what does e raised to power x look like? Okay, so now what I want to do, I want to draw a graph. Okay, so let's look here that what is e? E is 2.7. okay, I am rounding this off, right? So see, 2.7 and this is 1 and this is 8, right? So I can round this second digit to how much? I can round this 1 to 2, right? So I can say this is 2.72. okay, so here I am using this 2.72. so let's understand that 2.7 raised to power 0, what is x? 2.7 raised to power 0, yes, I can write this like this. This is basically 2.72 power x. Okay, so 2.72 power x, 0 is 1, yes, then this is how much? This can be written as 2.72 minus x. Okay, so let's draw the graph for x greater than 0. Let's draw the graph first. Yeah, let's so how to draw the graph? Okay, so to draw the graph I will take x and for that I will take the y. Basically I will take an input and I will take an output for that. Okay, so what is the input here? So let's say that if I take x as 0, if I take x as 0, what is the value of y? Value of y is 1. So this is the value 1, right? 1, right? So for x equals to 0, the value of y is 1. This is my x, this is my y. Next, for x equals to 1, for x equals to 1, right? What is the value of y? So for x equals to 1, the value of y is 2.72. So 2.72 will be somewhere here, right? This is t2. Okay, let's do one thing. Okay, so for x equals to 1, it will be somewhere here, right? Now let's move forward. For x equals to 2, x equals to 2, right? What is the value? Value is 7.3. So 7.39. Right? Okay, so the 2.72 will be somewhere here. Just give me 1 minute. We will draw this again. Okay, so let's do one thing. Let's write this 5, 10, 15, 20, 25. Oh, I should take more, something like that. Also, let's take something 10, okay, in the power range of 10. So this will become 10, 20, 30, 40, 50, 60, 70, 80, okay, and this is 1, 2, 3, 4, 5. Okay, so now let's draw this graph now. That for x equals to 0, yes, x equals to 0, the value is 1, so it will be somewhere here 1, right? For x equals to 1, the value is 2.72. So equals to 1, the value will be somewhere here 2.72, right? 2.72 somewhere here. For x equals to 2, it will be 7.3. So again somewhere here, right? So it will be somewhere here, okay? Now, for x equals to 3, the value becomes 20. So x equals to 3, yes, I will draw a graph. So x equals to 3, right? It will be somewhere here. So I will draw this point here. And for x equals to 4, the value is 54. So the x equals to 4, the value is 54. So somewhere here, x equals to 4, yes, the value is 54. So this is the point which I have here. And x equals to 5 is 148. So x equals to 5, somewhere here, 148 is somewhere here. So now what I'll do, I'll take these points and I will join this, okay? So if I join these points, yes, so what do you get? You will get something like this, okay? So just let me remove this. So once I remove this, yes, we get a graph something like this, okay? So this is an exponential graph, okay? What about negative values? Okay, so for negative values, okay, when x is less than 0, yes, for negative values, okay, this is 1, right? So now let's put x as 1. So if I put x as 1, this will become e raised to power minus 1, right? So minus 1 is here, minus 1, minus 2, minus 3, minus 4, minus 5. Okay, so what do I see here? That at x equals to 0, right, I have 1. X equals to 0, I have value 1. So it will be somewhere here. Then for x equals to 1, I have 0.37. So x equals to 1, I have 0.37 somewhere here. Correct? 0.5 will be somewhere in the halfway. Now 0.3 somewhere here. Again, this will be how much for x equals to 2? This is 0.14. So x equals to 2, 0.14 somewhere here. So what will happen now? This is continuously decreasing. Okay, so I will have something like this, a decreasing graph. So now when I combine both the graph, okay, so when I combine both the graph, what type of graph I will have? Yes, I will have something like this. So the graph for y equals to e raised to x. Yes, the graph for y raised to e power x, yes, is something like this. Okay, what is this value? This is 1. Okay, so what we have done, we have combined both the graph. Okay, this is for x greater than 0, this is for x less than 0, and I have combined both the graph to get this. Okay, so I hope the graph is clear. This is an exponential graph. Okay, is this valid only for e? No. Okay, if you take the value of, let's say, instead of e I take a, let's suppose if I take a as 2, right, so this will become 2, right, so 2 raised to power 0 is 1, same here, this will become 2, 4, 8, 16, 32, right. Okay, so this is how you can, the method is same. Okay, keep in mind the method is same, it is in similar way, but the only thing is changing that the value of a. Okay, so there is nothing different. I hope it is clear how you make exponential graphs. Okay, because this is very important and later on it will be very useful for you. Next. Okay, hello Raghav. So now graph of exponential functions I have drawn. So let's understand here. For a greater than 1, the graph increases exponentially. What do you mean by exponential growth? It is basically, it is increasing very fast. Okay, a rapid growth I have here. Okay, next, for a less than 0, sorry, greater than 0 and less than 1, the graph decreases, right, exponentially. So the graph decreases exponentially. Graph always passes through point 0, 1, right? Does it pass through 0, 1? Yes, this is the point which we are talking about, 0, 1. At this point, the value of x is 0, right, and y is 1. Next, at x equals to 0, at x axis y equals to 0 is a horizontal asymptote. Okay, so just if you don't understand this part, that y x axis y equals to 0, don't worry, we will cover this in the next class. When we will cover this? We will cover this in when I will teach you straight lines. Okay, after 1 or 2 classes I will be teaching you straight lines. So in that I will also teach you that y x axis is also known as y equals to 0. Okay, so I want you to please continue this transition course. Okay, this is a 3-week course. Okay, in this we will cover all the basics. Okay, so all the students who have joined, okay, please mark your calendars that from every day from 4 to 6:30, right, we'll have physics, chemistry, maths classes, and this is a very good course for you, so that you can bridge the gap between the 10th and the 11th. Okay, and later on you'll see the difference. Okay, the importance of this course also. Okay, so please join every day. Okay, so at x axis y equals to 0 is an horizontal asymptote. So now what is an asymptote? Okay, so asymptote you can understand. So you know what is an horizon, right? What is a horizon? So horizon is a place where the, so let's suppose if I go to Goa, right? If I go to Goa and if I am on a beach and I see, right? If I see far away, what do I see? That the ocean and the sky seem to meet at a point, right? But do they actually meet? No. Okay. Similarly, in this way, what is happening? That, see, the distance between the x-axis and this graph is continuously decreasing, continuously decreasing, continuously decreasing. Okay, but they are never going to meet. Okay, this distance will continuously decrease, keep on decreasing, but it is never going to be 0. So such lines are known as asymptotes. Okay, so x-axis. This x-axis is a horizontal asymptote for this graph. Okay, I hope this is clear. Okay, next. So what are the key properties? So domain, right? I talked about domain in the last class. Yesterday I talked about domain. What is domain? Yes, domain are the set of input values, right? Set of all the possible input values which I can have. So the domain here is minus infinity to infinity, right? You look here. If you look in this graph, yes, what are the values of x I can put? I can put x as 0, x as 1, 2, 3, any value I can put x, right? Negative values also I can put. So the real, okay, x belongs to R. The real number line is the domain. Okay, it takes each and every value is possible here. Okay, all real numbers are possible as input. Correct? Now what is the range? Yes, what did I tell you about what range is? So range is set of all the possible output values, right? I told you about the machine yesterday. If you go and check the class which I took yesterday in which I taught you functions, right? What did I teach you? That function is a machine in which I give you input and we get an output. So set of all the possible input values is known as domain, and set of all the possible output values is known as range, right? So what are the set of all the possible values? So here what is the range? So basically domain here, if you talk about that x, all the possible x values are the domain here and all the possible y values are the range here. Okay, it is not always true, but in most of the cases it is true that x is my input, y is my output. Okay, think this is an input, domain is defined for input and range is defined for my output. So here what is my output? Y. So what is the value? Let's look in the graph. So what are the possible values? So this is my y axis. So yes, is y possible value? No. You see that the value of this will never become 0, no, graph. So y is not possible. Is negative value of y possible? No. Negative value of y is also not possible. If you see, right, my graph is not below this x-axis. It is always above the x-axis. So what can I say? I can say that all the possible values are lying above the x-axis, right? So what should I say? If I want to write in terms of math, my range is 0 to infinity. Okay, 0 is not included, right? This is a normal bracket, right? It is not a square bracket. If I wanted to include 0, right, I will draw something like this. But I don't want to include 0, that is why I am drawing a normal bracket. And what about infinity? Infinity is a very large number, no? What is infinity? Infinity is a very large number, simple as that. Okay, how large I don't know. Okay, so we never include this because I don't know which number you are including. Clear? So next, f of 0 is 1, right? For x0 I will get value 1, for x0 I will get value 1. For x greater than 0 is for all x, right? The value of my function is greater than 0 for all x, correct? And continuous and smooth curve. Okay, what do you mean by continuous and smooth? So something which is continuous means it is not breaking at a point. Okay, so it is continuous and smooth, right? It is just like a slide, no, correct? So this is the properties. Okay, these are the properties of an exponential function. Okay, so I hope the exponential function is clear to you. Okay, and this will get more clear if you read about it more and solve questions. Okay, so don't worry, I have attached questions regarding this which you can find in the description box later on. Okay, and also join the Telegram group. Okay, I'll show you the link later on, but let's move forward. Okay, so the log functions. Okay, what is the log function? So log function is the inverse of an exponential function. Yes, we have learned about exponential functions. So what are inverse functions? General form. What is the general form? Fx equals to log. Now let's learn how to read this. Okay, let's learn how to read this. This is very important, reading of this. So this is known as base, and then this is known as exponent. So how do you read this? This will be read in this way. This will be log to the power of x base a, right? So what is this? Log to the power of x base a. Okay, and this is very important because log functions are also too much used. Okay, they occur very frequently in physics. Why they occur? Why exponential functions and log functions? Are these the only two what we say special functions? No, there are many functions, but right, students are afraid of these functions very much. Okay, so that is why they see, when we are afraid of something, the examiner keeps on asking these type of subject or concepts. So now, so general form is log x base a, log x to the power base a, where a is greater than 0 and a should not be equal to 1. Okay, means log x base a is equals to y is equivalent to a power y equals to x. Now what is this? Let's understand this. That when something is written like this, log x base a equals to y, there is a property. What can you do? Okay, you can just cross multiply this a here, just take this a here. So x, okay, remove this log, only you have x remaining here, is equal to, just 1 minute, let's write it nicely. So I can say that this will become x equals to, now this a comes here, right, and this y will sit on this a. So now this will become x equals to a power y. So this is why this is inverse of exponential, no? Right? If what was exponential? Exponential x is something a power y. Now if you overturn this, if I take this back again here, this will become this. Okay? So this is nothing, this is just an exponential thing. So now y a greater than 0, y greater than 0, let's understand again that if what is x equals to, so let's understand this again. See, this is inverse and we can use the same analogy here. So log x base a, right, log x base a is equals to y. So now I can say that x is equals to a power y, correct? Now let's suppose a is greater than 0, I have this condition. So let's say if I take a as minus 2 again, okay, I want to disprove. So what can I say? This will become x is equals to minus 2 power y, right? Again, if I take value of y is, let's say, 1 by 2, what will happen? If I take 1 by 2, this will become minus 2 power 1 by 2, this will become under root minus 2. Yes, and this is not possible. Okay, and this is not possible. So that is why this I have this condition. Second, a should not be equal to 1. Why a should not be equal to 1? I think you already know the answer. Why? It will become a constant function, right? We have already done this. So if I say that x is basically a power y, this will become 1 power y, right? So x is always equals to 1 here, because anything raised to 1 is 1 only, right? So this is a constant function. So what is a constant function? Constant function is something which doesn't change. Okay, if I keep on input, let's suppose if I have a machine and if I change the input values, my output is not changing, it is constant, something it is which is not changing, right here. Okay, so this is what we say a constant function. Okay, so that is why what we are learning log functions. No, this is constant function. So that is why these two conditions are put on this. Clear? So understanding the log functions, so let's understand. So 2 power 3 is equals to 8, right? We know that 2 power 3 is equals to 8. So how can you write 2 power 3? 2 power 3 can be written as 2 into 2 into 2, right? So this will become 8. But then log 2 base 8 is also equal to 3. So how do you get this? Okay, how do you get this? Okay, we'll talk about this. Okay, so basically let's understand. See, if I write this, this will become, okay, I can say that a power x is equals to y, right? So what can I say? I can say x is equals to log a power y, right? I did the inverse, no? That if I took a here and this x will go in the top, no, power, and I'll get y here. So same thing here, this is vice versa we can do. So let's just put the values, right? So if you see here, I'll get this is how much, 2 power 3 is equals to 8, and this can be written as, what is x here, 3 is equal to log 2 power 8. Okay, next. So same thing can be done for this, right? 10 square is 100, no? But how to write in log function, I'll help you with this also. So now e power x, okay, what is e? So e, so anything base, okay, so base can be anything, right? Base can be anything, base is a here, but the only condition is log, right? What is the condition? That in this log function, a should not be equal to 1 and should be greater than 0, right? But let's say if I take log as e, what is e? What is e? E is the value 2.7, it is something else. So I can just write that as ln, okay, ln x. Okay, whenever it is written like this, whenever it is written like this, ln, understand the base is e, and what is e? 2.7. Okay, so don't get confused here. Next. So now what is the domain, right? So what is the domain here? What are the set of all the possible input values? Okay, so if I draw the graph for this, if I draw the graph for a log function, okay, the graph for the log function looks something like this. Okay, and this is 1, this is 1, this is infinity, and this is minus infinity. So now what is domain? What is domain? Domain are the set of all the possible input values, right? So what are the values, input possible values I can give? 0 to infinity. If you check here, yes, this is my x-axis, right? So this is 0. So see, I have not included 0 because I will not be able to give 0 here. Okay, as I give 0, there will be a problem because a power 0 is 1, right? And 1 equals to y is not always true, correct? So that is why 0 is not included and any value greater than 0 is included here. So domain is 0 to infinity. Range, for range I will go to the y-axis, right? I will ask y-axis that, okay, in this y-axis, correct, what are the set of all the possible output values? Okay, so set of, I will write what is range. So whenever they ask you range, just say that set of all the possible output values. And what is the output here? Output is y. So I will go to the y-axis and I will ask the y-axis, okay, what are the possible values? So y will say, okay, 1 is possible, 2 is possible, 3 is possible, 4 is possible, minus infinity, everyone is possible. Below x-axis, minus 1 possible, minus 2 possible, minus 3 possible. Okay, so what can I say? That each and every value of y is possible here. So minus infinity to infinity. Okay, now passes through 1 comma 0, passes through 1 comma 0. What is 1 comma 0? This is x and this is my y. So this is my x and y. Yes, so this is x and this is y. Okay, now vertical asymptote at x equals to 0, right? What is asymptote? As I told you, asymptote is something which seems to touch but never touches, no? So this is my graph and this is my y-axis. So what you see that the distance between the y-axis and this graph is continuously decreasing, but they will never touch each other. Okay, okay, what will happen? It will look something like this, that yes, this is my, let's say that this is my y-axis and this is my graph. So it will be something like this, right? But it will never touch, it will never touch here. Clear? Next, increases slowly for a greater than 1, decreases slowly for a greater than 0 and less than 1. Okay, so increases slowly, it is increasing slowly, but if you see, there is a sharp drop from 0 to 1, it is going from 0 to infinity, right? Okay, so now properties of log function. So there are some properties which are very important here, which you should know. That what is this? Log a power 1 is 0. So how can you prove this? You can say that 1 is basically, so let's say that, okay, let's say I have this something like this, okay, log 1 base a is, let's say, y. So what can I say? 1 is basically a power y, right? And when is this possible? When a power 0 is 1. So here a power 0. So that is why y is equals to 0. This is how you can prove this. For log a base a, what you will say? You will say that, let's say that log a base a is equals to y, right? A is equals to a power y, right? So if you compare the exponents, I will say y is equals to 1. Okay, so these are two important things you should remember. Now here this is multiplication. So let's say if 2x and y are in multiplication, right? Let's suppose if I have something 8 and 8, I can write 4 into 2. So what can I say? I can just separate them. So log x into y is log x plus log y, with the base remaining the same. Similarly, let's say if I have something in division, log, okay, let's say something here I have x by y, right? So I can separate them with a minus sign in between, base remains the same. And finally we have log a x power r. So what happens? This power which we have here will jump forward. This power which we have will jump forward here. So when this power jumps forward, right? Have you done this kind of example? Yes, right? Let's look here. See this. Okay, let's understand this. When we have log 100 base 10, right? What can I say? This can be written as log 100 can be written as 10 square upon 10, and this will become, this 2 power will jump forward, so this will become 2 log 10 base 10. And what is log a base a? It is equals to 1, so this will become 2, right? So this is how you can use the power function. And log x base y, so you have x is the, y is the base, x is the exponent. So you can, now what can you do? You can, this is basically, we are defining a common base. So let's suppose if I want a common base, right? I can take this, that log x base a and log y base a. Okay, so now this base again becomes the exponent here. Okay, and finally we have log x base y, right, can be written as 1 by log y base x. Okay, the opposite, the base becomes the exponent and the exponent becomes the base. Okay, so these are some important properties which you should know. Okay, you should know, these are all the properties, not some, these are all the properties which are required in the log function. Okay, so now see, I have attached 3 questions for you, okay, in the presentation. Okay, so please try to attempt these questions, okay, by yourself. And I have also prepared a worksheet for you, okay, and what that worksheet is about, in that worksheet, okay, there are around 20-30 questions, okay. You try to solve that and you comment, okay, that I got this answer, and whatever doubts you have. So let's suppose if you will solve the questions, yes, you will have doubts, right? And to, like, doubt should be cleared, okay. So one thing you should learn is to clear your doubts, okay. Clearing doubts is very important part here, because see, what we are preparing for is IIT, JEE and NEET, okay. And in this, right, for 2 years you have to solve questions, okay. You have to rigorously solve questions. Solving questions is very important. And how will you solve questions? If you solve questions, you will have doubts. If you don't have doubts, means you are very great, okay. So the thing I want to say is that if you solve questions, you will have doubts, and you should clear your doubts. So how will you clear your doubts? You just scan this QR code, okay, and just write that in this session I have this question doubt, okay. I will connect, our team will connect with you, and we will clear and we will help you that to guide, okay, in this journey. Okay, also please join our Instagram, Facebook and Telegram channel, okay. Please join our Telegram channel, because we post so many things there, okay. Okay, there are so many activities which are going for students, okay, we provide notes, okay, planners, right? There are many NEET capsules, JEE capsules, okay, daily telegram questions, okay, which help you. See, small steps if you take, okay, they will lead you somewhere. So please join the telegram channel, okay, use this link and join us, okay, and let's meet tomorrow with a new session. Tomorrow we'll be starting with trigonometry, okay. I hope you really enjoyed this session and thank you for joining. Let's meet tomorrow. Thank you everyone.